Well, now we're going to do, in the first video, we did question 5.1, and now we're going to do question 5.2. The question says, I'm going to write here 5.2. Simplify, excuse me, the question says simplify the following expression to a single trigonometric function. So we do have a 4 cos of negative x times by cos of 90 degrees plus x, okay, all over sine of 30 degrees minus x times cos x plus cos of 30 minus x. Okay, I'll move this a little bit this way, times sine x. Sine x. So right now, we can reduce the trigonometric expression into by using some formulas, like formulas for reducing trigonometric functions. Like I start with the first one at the numerator over here. Okay, we have like, I mean, for this formula, for instance, we do know that cos of negative theta is equivalent to cos of theta. Okay, same thing. And then if I look at this one, cos of 90 degrees plus x, this is equivalent to cos of 90 degrees plus theta. Okay, this is equivalent to sine. This is equal to negative sine of theta. It can be reduced to that formula. And then I can notice also at the denominator over here, sine of 90 degrees, sine of 30 degrees minus x times cos. Okay, over here we have like 30 degrees minus x, and then also 30 degrees minus x, and then over here cos x, and then we have cosine x. So this tells me that what we call compound angles. Okay, so we can apply the compound angle formula over there, because we do know that cos of sine of a minus b, sine minus a minus b, this is equivalent to sine sine of a plus b is sine of a times cos b plus cos a times sine b. All right, so I'm going to use the formulas here, these formulas to reduce that expression. So at the numerator, that's going to become 4 cos theta, only because 4 cos x, 4 cos x, okay, because cos of negative theta is equivalent to cos theta, times cos of 90 degrees plus x. This is reduced to negative sine theta, negative sine x, so times negative sine x. At the denominator, okay, we have noticed compound angle here. It's like, those formula can be worked left to right and right to left also, because we have like at the denominator here, we have like the right hand side, so we want the left side. This can be reduced to sine of theta minus x, okay, plus x, excuse me, plus x. So this can be written as 4 cos x times negative sine x all over sine of 30 degrees. Okay, so now this is equal to 4 cos x, negative 4 cos x sine x. Okay, sine of 30 degrees is in the special triangle. This is equal to half. okay? And then this is equal to -8. Okay, if I apply it, if the first fraction, which is, okay, let me just write it over like this. So this is like -4 cos x sine x times a half, times 2/1, I mean. Okay, a fraction over another fraction, we do the first fraction times by the inverse of the other fraction. And this is equal to -8 cos x sine x. Okay, but now the question says, as we can see, they say to a single trigonometric functions, but here we have two functions, cos and sine. What else can we do then? Well, there's another formula which was not mentioned earlier that says this: sine of 2 theta is equivalent to 2 sine of theta cos theta. But now, as I said, the formulas can be simplified by using it from left to right and from right to left. In this case, when I look at from right, it's going to be from right to the left. But I don't have 2 here. This is -8. What else can I do then? All right. The -8 cos x can be written as like this. This can be written as -4 times 2 cos x sine x. Okay, sine x, because -4 times 2 makes -8, and then this part here is exactly that one. Okay, so we can substitute there. This is equal to -4 sine of 2x. Now we have a single trigonometric formula or function. Thank you.